So by now you've had a few weeks of practicing taking cuttings. Let me now give you some tips that will apply to most types of cuttings. Some things are new and some things are review. So tips on cuttings. As we've talked about, the ripeness or the age of the stems used as cuttings is key to whether they will root or not. So some cuttings will root readily from the stem tip, the softwood or greenwood, and some will root more successfully if they are taken from ripe or semi-ripe wood. And the riper it is, the woodier and the older the tissue is, the less likely it is to rot because it doesn't have a lot of green succulent water in it and tissue, but it also is harder to get it to root. So there's a trade-off between ripeness and rooting and early maturity and rooting, which the early maturity, the softwood and greenwood will root much more readily, but they also rot more easily too because there's so much more water in them. Tissue types to avoid when you're doing cuttings or to cut off of your cutting is anything with pests on it, any little pieces of decay or damage. A torn stem or leaf is not nearly as good as a clean cut because there's a lot less surface area on a clean cut than a tear. That would be a damaged tissue that you'd want to snip off. Decay can look like a blackened stem or even just a brownish spot that's forming that will become decay. And those are all areas that are vulnerable to some kind of attack, fungal and even bacterial. Tissues to utilize as cuttings typically use horizontal shoots with regularly spaced nodes, not too far apart. And the shoots that are really stretched out with the nodes really far apart are quick growth, and they tend to not be very successful. They tend to rot pretty easily. Juvenile foliage is best. That roots more readily. Prune back an older shrub to produce more juvenile foliage. You can cut back an older shrub down into some of the semi-ripe tissue or woody tissue, and it will send out shoots, new shoots that can be used for semi-ripe softwood or greenwood cuttings. Cuttings should be in between really thin and really thick. So you don't want really thin tissues like the size of the diameter of like a phone charger cord or something. Just really delicate is probably not going to make it and root. So you want something a little thicker, but not so thick that it doesn't root. Your pinky finger diameter is really good for a lot of cuttings, especially woody cuttings. It can be smaller than that. More like a pencil size is really good size for a semi-ripe or ripe cutting. And for greenwood and softwood cuttings, pencil shape, pencil diameter, or maybe a little bit smaller would also be fine for those greener cuttings. Take cuttings from the current season's growth. Usually, not always, some of the hardwood cuttings do not have to be from the current season's growth. And greenhouse grown plants in good condition can be used as a mother plant for cutting. So keep that mother plant growing well in a healthy situation so she can keep producing more new growth to take more cuttings from. Another piece of information that can help you with more rooting success on your stem cuttings. Consider the negative correlation between the stem maturity and its ability to produce roots. As the maturity of the stem decreases, so as you go from ripe to the softwood, the rooting capacity increases, as I said before. The younger the tissue, the more likely it is to root. Also a negative correlation between high temperature and rooting. So it's a little bit more complex. But as the temperature increases in the greenhouse or the place that you have those cuttings and you're trying to root them in their media, they will root better and better up until about 80 degrees. So around 80 is prime for like bottom heat or even in the greenhouse itself to induce rooting. But over 80 degrees decreases rooting. So you don't want it too hot, but you do want it up around, we usually keep our greenhouse around 76 degrees or our heating mats around 76. Also consider the positive correlation between the rooting of the stem cutting and dormant season. For in particular deciduous fruit trees. Thus, the dormant cuttings root better in general for temperate climate fruit trees. So temperate climate fruit trees are things like our pomes, apples, plums, nectarines, peaches, things like that. Um, you add auxin or indole butyric acid, the IBA, which is in our rooting hormone, that can overcome that seasonal variation, and so you can still get good rooting even if it isn't the dormant season. Negative correlation for tropical trees, the growing season, hardwood cuttings, so you're taking ripe stem cuttings during the growing season, not the dormant season, and those tend to work better for tropical trees, for example, ficus. And if you do add IBA, the rooting hormone, it does not tend to overcome that seasonal variation in ability to root. And you can see the bottom line, the red dots are for the tropical fruit trees and other trees, and the green lines are for the temperate climate fruit trees. Let's take a moment to talk about node and internode cuttings. So remember that nodes are places along the stem where new cells are created. So that's a place where a leaf might come out, or a new stem, a new branch of that stem. This is a passion vine. So you're seeing leaves come out, and also tendrils can come out. Those are the nodes. And in between those growth points is called the internode. And when you take a cutting, you cut just below the node for the lower cutting, and you cut just above a node for the top of this passion vine. You can see on the left is the lower node, the closer to the ground along that vine, and the cutting was done just below the node. And there was also the top cut was just above the leaf or that node. It's a little bit harder on passion vines too, because the leaves sometimes will kind of bend around and look like they're facing up, even though they were facing down, so it gets confusing which is up and which is down. So it's something that has to be remembered when you take the cutting, which was the part closest to the ground along that stem, because you don't want to put a cutting in upside down. It won't work. You can do internodal cuttings too. Some plants, it doesn't matter that much, but you have to remember that that tissue between the place you make the cut on the internodal cut, let's say where that person's fingers are, you took a cutting, right? You cut that stem right between those two nodes. You have a pretty good section of internode there. That internode tissue will not be part of this cutting plant as it matures. That tissue from the cut you make all the way down to the node will eventually rot or wither away. So it tends to be a place where infection can happen. The closer you can cut to the node, the better, because the node is the place that can put out special healing hormones and compounds that will heal over that wound. If those compounds have to travel from the node all the way to the middle of the internode, they probably won't do a very good job of healing off that wound as well, and you can have infection. So the takeaway is, when you do your cuttings, cut close to the node. If it's the bottom cut, cut just below the node. I like to do at an angle, not everyone does. And if it's the top cut of that cutting, make it just above a node. One stem, as you can probably guess, can produce many cuttings. This one has only 2 nodes in it, and it can work for some species, especially when you get really good at it. Try to make all your cuttings, if you're doing this especially in mass quantities, do all your cuttings of similar maturity, similar length, size, diameter. So when you see hundreds of cuttings that you've made, as they start to root or not, you can better judge what the problem is. If all your cuttings are different sizes and lengths, and you put them into the pots at different times, you'll never really know why some are failing and some aren't. So if you kind of take out all of those factors, or you make uniform all the factors of size and maturity, then you can better figure out what's going wrong when there is a problem. More tips for cuttings. On the preparation side, collect the material from the mother plant early in the day. Store those cuttings if you need to, if you're not putting them into media right away, in a clean plastic bag and label, and keep it in a cool, dark place. A refrigerator is fine, like in a Ziploc bag. And that'll last even longer if it's in a fridge. If it's in a cool, dark place like a cooler or just a shady spot, then you can keep it for a couple of hours. Try to keep all the surfaces sterile when you are doing these for like your business. You want to make sure all your equipment, your tools, your clippers are sterile when they're used between different plants, and sterile media, sterile pots. That's all a really good practice for commercial propagation. A little bit about the media for cuttings, roots and shoot cuttings. There's lots of different types of media that can be used. We're using 100% perlite. We're also using a potting mix. The brand name is Sunshine Mix number 4, which has peat, and it has perlite, and it has a little bit of minerals in it. You can also use equal parts of peat and perlite, or equal parts of peat and bark, or all perlite like we're doing, or even something called rock wool. And rock wool is a substrate used mostly in hydroponics. It's made from spinning molten basaltic rock into these little fine fibers, and then those are pushed together and smushed together to form cubes and blocks that function like a soil. They can hold some water, but they're also very well drained. Fungal spraying before applying the hormone is important. It can, fungicidal, I should say. So that sometimes is mixed in with the rooting hormone. So you dip in the rooting hormone, and it already has a fungicidal action to it too. So it'll kill fungus that could cause it to rot while stimulating root growth. There's liquid dip and grow. We're using powdered. They're both the same thing, just in different forms. Keeping them moist immediately upon planting them is important. Keep the moisture around that cut surface in the stem. Don't let them dry out at any time. Of course, as soon as you see dead cuttings, remove them. Keep them out of direct sunlight, but light is good, just not direct light. And once they get roots, then you can fertilize them. But really, your media does not need any fertilizers or any nutrients in it until they have roots, because there's no way to take those nutrients up until they have roots. So those are some tips. Let's talk a little bit about softwood cuttings and things that can help the success of those. So this is the green new growth. So these cuttings are taken from plants in the early spring and summer, anytime the plant is actively growing. So mostly it's kind of from spring until early summer, when water decreases and the plants get a little bit less actively growing. So before the new growth firms up, so when it's bent, it doesn't snap, it's still very flexible. It's good for most deciduous shrubs and vines. That's what we'll be doing with the passion vine, for one example. In general, you want your cuttings about 6 inches, 4 to 8 inches long from the tip. 2 to 3 pairs of leaves at the top. I like to leave just one leaf at the top to reduce transpiration and water loss possibility. Take the soft tip from each of those cuttings, and that's vulnerable to rotting and scorch, and remove that. And then take cuttings from behind that. Keep the cuttings clean and moist until planted. Make a hole in the media prior to inserting it in with a little pencil, something like that, so your rooting hormone doesn't get kind of wiped off as you're pushing the stem through soil if there was no hole. You can have the fungicide. It can be in the rooting hormone. It can be applied also afterwards, before the stem cutting is put into the media, or it can be watered with a fungicidal water solution. Keep them in a warm area with a bottom heat, protected, and from indirect light, as was said before. And around 76 degrees is the prime temperature to promote rooting. Also, something that might come up for you, that would be good for you to know, would be the distinction between water sprouts and suckers. Water sprouts are shoots that arise from the trunk of the tree or from lateral older branches, and kind of grow almost like in a different angle, like straight up through the tree, where most of the branches are kind of spreading out, going laterally, and the water sprout will come off of the more mature wood. After that, those other branches have already established, then you get these things that kind of just shoot up through the middle. It's not as strong of wood, fast, kind of weak growth, produces very little fruit and poor quality, and usually just crowds the branching. So those are things you do want to prune off. But they can be used as a cutting, um, but because they're fast growth, they tend to be more elongated, and the nodes are further apart, so they're not the best for taking stem cutting. So just know the distinction between those two. Suckers are the other thing that grows quickly, but it grows off the rootstock or the bottom of the tree. So it tends to be, those would be fine if you want to take cuttings from those to grow more rootstocks. Root those for rootstocks, where you would graft the top part, the scion, onto that. But you wouldn't want to use that as the whole organism. So if you took some cuttings of suckers, rooted them, and grew them up, they're not going to have good fruit on them like the tree did, because they come from different genetics. A graft is taking the rootstock has certain genetics, and you graft a different branch on top of that, so the bottom part of the tree has completely different genetics, maybe not completely, but very different, to be resistant and hardy in that soil and climate. And the top part, the genetics are just to produce the really good fruit. So if you take suckers as a cutting, know that you can grow more rootstocks from that, but they wouldn't be good for a scion wood or for growing up all on their own. Greenwood cuttings, a little more mature than softwood. They're similar. Just take those cuttings when new growth is just beginning to firm up. When it bends, it does snap. It has a little more of this compound called lignin, which makes the cells in that plant tissue more rigid. A little easier to handle. It doesn't wilt as easily as softwood. It sometimes can look the same color, but sometimes getting a little bit maybe tan or lighter green, meaning that it's hardening up. Those are, but some plants that do really well by these greenwood cuttings, like fuchsias, camellias, heliotropes, just for a couple examples, they do very well, and you can take that greenwood, and it will do just fine. It wouldn't do as well with the stem tip, but a little back from the tip works better for these plants. And every plant that you're going to try to propagate, it's not like you have to remember all the different ones I gave you in these lectures or in lab. You're going to be looking up. Whenever you have to propagate something new, you can easily look it up. What's the best tissue to use? This information is very accessible to you online in some books. You can always ask me, even in the future, but also other plant propagators. Most of the people that grow and propagate plants in our area, here around Santa Barbara, are very willing to share what they do for propagating. There's not a lot of proprietary information, so that's good too. Always ask someone that already does it, and you'll get the real details on the best way to do it. Some tips for semi-ripe cuttings. Semi-ripe cuttings can be handled in a lot of the same ways that the other cuttings are, but there are a few details that are a little different. You collect the cuttings a little later in the season, like late summer or early autumn, when that New Year's growth has started to firm up even more. The base of that perhaps branch or cutting is firm, and the tip can be still growing, but you're using the part that is a little bit more mature. That you need to take the cuttings that are not too firm, but also not too soft or leggy, just somewhat in between. Usually they're turning a little brownish or reddish. About 4 to 6 inch length is good for most. Wounding helps these maturity of cuttings a little more because they're a little bit harder and more thick. You can expose the cambium, and it can help promote rooting. Lots of plants that respond well to semi-ripe cuttings have grayish leaves. It's their natural adaptation to dry climates where there's a layer of wax or hairs on the leaf surfaces, which keep the leaves more humid overall in a dry environment. These cuttings you want to be put in an environment after you take the cuttings and pot them up. Don't put them in a place that's super humid like you would for something that isn't grayish, because they already are humid because of their own adaptation. That creates that gray color. So you want to reduce the chance of rotting by putting them in a less humid environment for cuttings, for trying to get those cuttings to root. Semi-ripe cuttings, because they're a little bit more hard and dormant tissue, takes a little longer to mature. They can take 2 full growing seasons for the roots to really develop well. Mallet cuttings, you can see some that are circled in the image. They are used on pretty difficult to root shrubs. The one I know the best is Ceanothus, which is a very popular native plant here in the southwest United States and very commonly propagated and sold here. But that mallet cutting is just what it sounds like. You have a branch cutting a stem, and then you're taking a little section from the mother tissue, so the branch that you're cutting came off of. And that increases the amount of cambium. It kind of doubles the size of the cambium exposed and the surface area for potential rooting. It just seems to work really well for certain species that are difficult to root in other ways. And you're seeing a picture of them there that are circled are the mallet cuttings, but then on the right, bottom right, is what we'd call a pulling. You take a branch and you pretty much literally pull it off, and you get a big strip of tissue from the mother branch as well, and that works well on other. Here's a picture of a heel cutting. A type of heel cutting is this called a pulling. Sometimes they're used interchangeably, but what I described in the last slide. They're pulled from the parent twig, and you get additional cambium and those meristem cells that produce the hormones which encourage root growth. And again, the cambium is that layer of actively dividing cells just inside the outside of the stem, just inside the bark, between the xylem and the phloem. And it's responsible for growth or new stem tissue, new cell division in stem tissue comes from the cambium layer. All the other layers don't produce their own cells, but the cambium does. So that's the place where we can induce those cells. They're like stem cells in animals. We can induce those to form roots, adventitious roots off of that stem tissue. Some other types of cuttings that are a little less common, but leaf bud cuttings, where you take a little section of the stem with a leaf and it has a bud in it. These are taken in late summer or early autumn, usually include at least 2 nodes, and they can be done with internodal cuttings too that work fine. You trim the leaves of the large leaf plants off and leave just one of the buds there. The wounding isn't necessary unless it's semi-ripe or ripe. Some tips about hardwood cuttings. So lots of different evergreen and deciduous shrubs and vines are successful when you use hardwood cuttings. Things like dogwoods, willows, grapes, mulberries, elderberry, lots of things. Season of taking the tissue is late autumn or midwinter, in the dormant season. Usually you're using a pencil to pinky diameter of a cutting, about 8 inches long. Wounding is even more helpful the more mature the wood gets. So nick or scrape off the outer layer of bark. Put it in a very well-draining type of media, potting mix or perlite. Those are good, and it's going to have to stay in there a long time. These take a while to root, usually 3 to 6 months. Planting them, you plant them deeper usually than you would other cuttings, where there's only 1/4 to 1/3 of the cutting exposed, and keep them moist for a long time. Bottom heat for only the first few weeks. I've done it longer, but that is recommended that you don't keep it on there the entire 3 or more month period. Now let's also talk about botanical nomenclature as another subject in this week's lecture material. So the naming of plants and the naming of cultivars and how that works. Something that will come up again and again, and I like to talk about it pretty early on in the semester so it's not confusing later. Nomenclature just means the system of naming. That governs how plants are named, and then it determines how they're written and pronounced too. It's always a little confusing to learn Latin names, but those are good to know in addition to the common names. The common names can be confusing because the same common names are applied to different plants sometimes. So almost all organisms on Earth are classified with some form of nomenclature, including humans. And sometimes the common names are used to identify them, and like I said, that can be easier to remember, but we also need to know the Latin or scientific name as well. In scientific naming or classification, use the binomial nomenclature system, where there's 2 names, binomial, 2-part name to every unique species. Like humans are Homo sapiens. Homo is the genus, sapiens is the species, and overall Homo sapiens is the name of the human species. Scientific naming uses, as I said, binomial or double name to each organism. The first part is called the genus. The second part is called the specific epithet, or the species. But overall, when you look at a plant, and you're saying, what's that plant out there, that oak tree? It would be called, for example, the coast live oak would be Quercus agrifolia. Quercus is the genus, agrifolia is the second part of the name, the species name, and altogether the name of that coast live oak has two parts. It's Quercus agrifolia. So two-parted name, the genus and the species together make the name of the species. The modern system, this binomial nomenclature system, was developed by the Swedish physician Carl von Linné, or Linnaeus. And he's even on some of their currency. So you got to like a country like Sweden that has a botanist on their money instead of a politician. The system is based off of classifying the parts of plants, mostly using the reproductive parts, the flowers, to give the plants specific genus and species. They're categorized by their reproductive organs for the most part. Like you have, for example, sunflower family plants all have very similar flower parts. Rose family plants have very similar flower parts that are different than the sunflower family. And that's how they're divided up and named according to their family and their genus and their species. So the first part of the scientific name is the genus. Let's take, for example, this plant in the image, hummingbird sage, Salvia spathacea. The genus is Salvia. There are other types of salvias. So the genus is a category which within there are a bunch of different plants in that Salvia genus. And then the species name, the spathacea part, the specific epithet is the second part of its name, that there are a bunch of different types of species of salvia. And there you have it. The scientific name is used as a noun in the nominative singular case, and it's always written either in italics or underline. That indicates a foreign language when you're writing it. It's in Latin. It's a foreign language. So let's look at the second part of the scientific name, the species part. It's almost never capitalized. Our example of Salvia spathacea, the hummingbird sage. The salvia part is capitalized, but the second part, the species part, is not capitalized, spathacea. So the genus is capitalized and the species is not. The confusing thing about scientific names, the way I'm describing them, is that second part of the scientific name is called the species name. But the actual name of the whole plant is both parts, the genus and the species together. You would look at a hummingbird sage and say, oh, that's Salvia spathacea. So that's the species name, but it's also the name of that second part of the scientific name. More technically, that second part is called the specific epithet. So it's the species ending of that phrase. So anyways, remember that both parts, the genus and the species together, make up the unique name, just like they do for humans, Homo sapiens. We don't look at a human and if, we're an anthropologist looking at a bone of a human saying, oh, that's sapiens, we would say Homo sapiens, although the sapiens part is also referred to as the species part of the name. So the species part of the scientific name, it is normally not capitalized, but sometimes it is. Rare occasion, if it's directly derived from a person's name or a commonly used vernacular name or from the name of a genus. For example, Picea breweriana is brewer's spruce, and it is named to honor the American botanist William Henry Brewer. So it's named after a person, and that is honoring him, so we would capitalize it. But normally you don't have to worry too much about that. There's some technical details. The species name is an adjective, usually that describes the genus, which is a noun, and it agrees in genus name and in case and number, so it has to match it, especially in plurality or singularity. So that's something to think about too. And Again, not too important unless you get really into naming them yourselves, but it helps you remember some of the scientific names to know some of these rules. If you're abbreviating species, SP period is the abbreviation for singular, SPP is for multiple. Let's say you were writing down a list of species for a client, and you knew they wanted, and you were going to plant a bunch of different salvia species on site, but you hadn't decided exactly which ones. You might write up your plant and say, these different salvia species will be planted salvia SPP dot. So that means a variety of different salvia species will be used, and it's not indicating which ones, but there's more than one. Some species in the salvia genus. If you found a plant and you weren't sure what it was, but you knew it was a salvia, you wanted to write that down and tell someone about it kind of in text form, you would say salvia SP dot. So it's some salvia species, you're not sure which one. We've talked enough about hummingbird sage. Let me just give you a little bit of information about that really cool plant. That's very common and popular and beautiful and native here in Southern California. Salvia is the genus. It refers to, in Latin, healing, helping, or saving. The species name, it refers to anatomical part of the plant, Spathaceae with a spathe, and it's a large bract. It's kind of like a petal below the flower that encloses the flower cluster. You can see them in this image. You see the bright pink tubular flower, and then there's kind of a dark purpley brown thing underneath it that really surrounds the flower and protects it before the flower opens up and pops out. That's a spathe. So that is a scientific name. That species name is describing the plant's part of the plant structure and describing its, that genus was named for its uses. So many salvias have healing uses in salves, etc. So it's descriptive. These Latin names, sometimes when they're named after a person, it's nice to honor people, but I tend to like the names that are descriptive. They help you remember, what the plant is, and if you don't know the scientific name, it makes sense when you read it, when you kind of know what the Latin means, because they are descriptive of the plant itself and not just naming some person. Some other terms that might come up when learning about the naming of plants. Subspecies, that's a geographic race of a species. So you have a certain species that grows maybe all over California, like Epilobium canum, but a subspecies of that species may grow in only a particular geographic area and have unique qualities to it, characteristics, and that would be a subspecies. Epilobium canum, subspecies, SSP, canum. That is also known as California fuchsia, and there are a number of different subspecies that look different, grow differently, but they're all the same species, just different subspecies. A variety is a smaller group or race not deserving the subspecies status. It's not quite that different, but it's labeled with a VAR, or V is are the abbreviations for how the name is written, like Solanum, like a persicum, var, or variety, Ceraciforme. So that is a native nightshade here in California. Form, another term, is a seedling variation used when a percent of seedlings exhibit a distinctive characteristic and labeled with an F. So that's just, I don't see that too often, but in propagation you might see that now and then. Cultivars, it's a combination of the words cultivated and variety, just a kind of a made-up word, cultivar. It's labeled or abbreviated as CV period, and it means a hybrid of a plant that humans have developed and humans have to maintain. And that's the way they're propagated, and they're always cloned. But if you let them go to seed, they would go back to their wild type. An example of a cultivar would be something like Teucrium fruticans, azurium, and the cultivar name is sometimes put in single quotation marks after the species to tell you that this is a type of Teucrium, which is a really pretty grayish bush with really pretty little purple flowers that you see in the image there. and but this is a something that's been hybridized and bred by humans to have special qualities from that naturally occurring Teucrium fruticans, a more beautiful one, maybe more marketable one, and that is a cultivar. And again, you see those cultivar names in single quotes after the species name.